Ever wonder what's truly out there beyond the latest AI advancements and virtual realities? Forget the noise and screens for a moment. What if I told you the universe itself holds the ultimate trending topic, a subtle symphony of cosmic forces, so gentle, they can lull you into the deepest, most peaceful sleep imaginable? Get ready to explore the unseen, not with equations, but with pure wonder. Take a deep breath, and let yourself settle into this moment. Close your eyes if you wish, and imagine yourself floating gently through the vast emptiness of space. The stars around you twinkle softly, like distant lanterns guiding you through an infinite sea of darkness. But what you see is only a fraction of what truly exists. The universe, in all its majesty, is woven together by invisible threads you cannot touch, cannot see, yet they are there, holding everything in a tender embrace. These invisible architects have names whispered by astronomers in hushed, reverent tones: dark matter and dark energy. They are the silent guardians of reality, the unseen forces that shape galaxies and guide the expansion of space itself. Unlike the blazing stars or swirling nebulae that capture our imagination, dark matter and dark energy work in quietude, never announcing their presence, never demanding attention. They simply exist, patient and eternal, weaving the cosmic tapestry that cradles all of existence. Let us begin with dark matter, the gentle keeper of galaxies. Imagine a spiral galaxy, its arms reaching outward like a cosmic pinwheel, spinning slowly through the void. The stars you see, brilliant and luminous, are only a small part of this celestial structure. Surrounding them, invisible to even our most powerful telescopes, is a halo of dark matter, an ethereal cocoon that embraces the galaxy without ever making contact. Think of it as a ghostly net, impossibly light yet impossibly strong, holding the galaxy together through the gentle pull of gravity alone. This dark matter does not shine. It does not emit light or heat. It does not interact with ordinary matter in ways we can easily detect. Yet we know it is there because of what it does, the way it influences the motion of stars, the way it bends light from distant galaxies, creating soft arcs and distortions in the fabric of space. Picture these invisible halos as protective spheres of influence, like the warmth of a blanket you cannot see but can feel wrapping around you on a cold night. Dark matter holds galaxies together, preventing them from flying apart as they spin through the cosmos, a silent guardian working tirelessly in the shadows. Scientists believe that dark matter makes up about 85% of all the matter in the universe. Let that sink in for a moment. Everything you have ever seen, every star, every planet, every grain of sand on every beach, represents only 15% of the matter that exists. The rest is hidden, woven into the universe like invisible stitches in a vast cosmic quilt. It is humbling, isn't it? To realize that most of the universe operates beyond our perception, content to remain unseen, performing its role with quiet dignity. Now, let us turn our attention to dark energy, the other unseen architect of reality. If dark matter is the gentle keeper that holds things together, Then dark energy is the patient expander, the force that gently pushes everything apart. Imagine the universe as a vast ocean, and dark energy as a soft, persistent current that carries everything slowly outward, creating space between galaxies, between clusters of stars, between the grand structures of the cosmos. It works so gradually, so tenderly, that you would never notice it in a single moment, but over billions of years, its effects are profound. Dark energy fills the empty spaces of the universe, the vast voids between galaxies where nothing seems to exist. But these voids are not truly empty, they are filled with this mysterious energy, this gentle force that counteracts gravity's pull. While gravity wants to bring everything together, dark energy whispers a different story, encouraging expansion, creating room for the universe to breathe and grow. Picture it as the universe exhaling slowly, stretching itself out like someone waking from a long, peaceful sleep, arms reaching outward in a contented yawn. The discovery of dark energy surprised astronomers. They had expected the expansion of the universe to be slowing down over time, gravity gradually reeling everything back together. Instead, they found the opposite: the expansion is accelerating. Galaxies are moving away from each other faster and faster, driven by this invisible energy that permeates all of space. It is as if the universe has decided it prefers spaciousness, choosing to create vast, tranquil expanses where silence reigns and stillness prevails. In these cosmic voids, there is nothing but the gentle hum of dark energy, working patiently, tirelessly, forever. Together, dark matter and dark energy form a partnership that shapes the universe's destiny. Dark matter provides structure, gathering ordinary matter into galaxies and clusters, creating islands of light in an ocean of darkness. Dark energy provides expansion, ensuring that these islands drift slowly apart, maintaining the grand scale and majesty of the cosmos. They work in harmony, these unseen forces, like two dancers performing a silent ballet that has lasted for nearly 14 billion years. As you float through this invisible landscape in your mind, feel the gentle tug of dark matter, the soft embrace that holds the stars in their places. Feel the whisper of dark energy, the patient push that creates space and tranquility between the celestial structures. You are surrounded by forces you cannot see, yet they are as real as the breath moving through your lungs, as constant as the beating of your heart. The universe is not just what you observe, it is also what you cannot observe, the hidden dimensions of reality that work silently to create the world you know. Let yourself sink deeper into this understanding. There is no need to grasp every detail, no equations to memorize, no tests to pass. Simply allow yourself to drift through this knowledge like a leaf floating gently down a calm stream. The invisible threads of reality are always there, whether you think about them or not, holding everything together with infinite patience and grace. Rest now, knowing that the universe itself is woven from unseen beauty, and that you are cradled within its gentle, mysterious embrace. Now that you have drifted through the invisible threads of dark matter and dark energy, let us turn our attention to something even more ancient, even more pervasive, Imagine, if you will, a gentle hum that fills every corner of the universe, a whisper from the very beginning of time itself. This is the cosmic microwave background radiation, and it is singing to you right now, a lullaby that has been playing for nearly 14 billion years, patient and constant, never ceasing, never changing its tender melody. Close your eyes and picture the universe in its infancy, just a few 100,000 years after the moment of creation we call the Big Bang. The cosmos was much smaller then, much hotter, filled with a brilliant fog of light and energy. Everything was so densely packed, so intensely bright, that light itself could not travel freely. It would scatter and bounce off particles like a flashlight beam trying to pierce through thick mist. The universe was opaque, glowing with the heat of its own birth, like an ember fresh from the fire. Then, gradually, as the universe expanded and cooled, something remarkable happened. The fog began to clear. The temperature dropped just enough for atoms to form, allowing light to finally break free and travel through space unimpeded. This moment, called recombination, was like the universe taking its first clear breath, and the light released in that instant has been traveling ever since, crossing vast distances, growing gentler and cooler as the universe stretched and expanded around it. That ancient light still surrounds us today, though it has changed. As the universe expanded, the light stretched along with it, its wavelengths growing longer and longer, shifting from visible light to infrared, and finally settling into microwave radiation, invisible to our eyes but detectable by special instruments. This is the cosmic microwave background, the afterglow of creation, a bath of gentle radiation that fills all of space uniformly, arriving from every direction at once, like being immersed in an infinitely vast, warm pool. The cosmic microwave background has a temperature of just 2.7 degrees above absolute zero, the coldest possible temperature in the universe. It is the chill of deep space, the coolness of ages, yet it carries within it the memory of unimaginable heat. Think of it as the universe's own body temperature, a baseline warmth that pervades everything, so subtle you would never notice it without sensitive equipment, yet so constant that it defines the average temperature of existence itself. What makes this radiation so soothing to contemplate is its uniformity. No matter which direction you look in space, the cosmic microwave background is almost exactly the same temperature, the same gentle presence. It is like a cosmic blanket draped evenly across the entire universe, with only the tiniest variations, subtle ripples in an otherwise perfectly smooth fabric. These tiny fluctuations, just millionths of a degree different from one spot to another, are the seeds from which galaxies would eventually grow, but they are so delicate, so minimal, that they speak to an underlying harmony in creation. Imagine lying on your back in a field at night, looking up at the stars, but instead of seeing visible light, you could somehow perceive this microwave radiation. You would see a soft, even glow surrounding you on all sides, a gentle luminescence with the faintest patterns swirling through it like wisps of cloud in a pale sky. These patterns are fossils from the early universe, imprints left by sound waves, yes, sound waves, that rippled through the infant cosmos before atoms even existed. In those first moments after the Big Bang, the universe was filled with a plasma of particles so hot and dense that pressure waves could travel through it, creating oscillations, vibrations that moved matter back and forth like ripples spreading across a still pond. These primordial sound waves, though they occurred in a medium nothing like our air, were real vibrations in the fabric of the early universe. And when the universe finally cooled enough for light to escape, these vibrations were frozen into the pattern of the cosmic microwave background, like a photograph capturing the exact moment a bell finishes ringing. Scientists have even translated these patterns into sound, creating an audible version of what the early universe sounded like. It is a deep, resonant hum, a tone so low and so ancient that it speaks of depths beyond human experience. This is the universe's first voice, its first song, and the cosmic microwave background is the echo of that song, still playing softly all around us, a lullaby that has never stopped since the moment it began. What is truly remarkable is that this radiation reaches us from every direction because we can see, in effect, the entire sphere of the observable universe at the moment light was set free. Everywhere we look outward, we look backward in time, and at the farthest reaches of our vision, we see this same ancient glow. It is as if the universe has wrapped itself around us in concentric shells of time, and the outermost shell we can perceive is this gentle, cooling light from our cosmic childhood. The cosmic microwave background is also incredibly smooth, incredibly uniform, which tells us something profound about the early universe. For it to be so evenly distributed across all of space, conditions in the infant cosmos must have been extraordinarily well mixed, as if everything had been in contact, in equilibrium, before expansion carried it all apart. This uniformity is one of the great mysteries and great beauties of cosmology, that the universe began in such a balanced, harmonious state. As you contemplate this gentle radiation bathing all of space, let yourself feel connected to it. Every point in the universe receives this same soft glow, this same ancient light. You are immersed in it right now, though your body cannot sense it directly. It passes through you constantly, harmlessly, carrying with it the story of creation, the memory of a time before stars, before galaxies, before anything solid or familiar existed. You are being touched by light that has been traveling for nearly the entire age of the universe. Let this knowledge wash over you like a warm wave. There is something deeply comforting about the cosmic microwave background, its constancy, its universality, its gentle presence. It is the universe's way of reminding us that we all share the same origin, the same ancient moment of beginning. No matter how far apart things may drift in space, they are all still bathed in this same primordial light, still connected to that first moment of clarity when the fog lifted and the cosmos became transparent. Rest now in this understanding. The universe is humming its ancient lullaby, a song of microwaves and memories, of light stretched thin by time and distance. It asks nothing of you except to exist within it, to be part of the grand tapestry it has been weaving since the beginning. Let the cosmic background radiation be your blanket tonight, wrapping around you from all directions, holding you in its gentle, timeless embrace as you drift deeper into peaceful sleep. As you float deeper into the cosmic embrace, cradled by ancient light and invisible forces, let us descend now from the vastness of galaxies and journey inward, toward the smallest scales of existence. Here, in the realm of the infinitesimally tiny, the universe reveals another secret, another layer of gentleness that defies our everyday understanding. Welcome to the quantum world, where particles dance in clouds of possibility, where nothing is certain until observed, and where reality itself seems to breathe with a soft, probabilistic rhythm. Imagine holding a grain of sand between your fingers. Now imagine dividing that grain into smaller and smaller pieces, first into molecules, then atoms, then the particles that make up those atoms. Keep going, deeper and deeper, until you reach the fundamental building blocks of matter, electrons, quarks, photons. At this scale, something beautiful and strange occurs. The rules that govern our everyday world, the predictability, the solid certainty of objects having definite positions and speeds, begin to dissolve like morning mist touched by the sun. In the quantum realm, particles do not exist in single, definite places. Instead, they exist in what physicists call a superposition, a word that means they occupy many places at once, spread out like a gentle fog across space. An electron orbiting an atom's nucleus is not a tiny ball traveling in a neat circle, as old diagrams might suggest. Rather, it is a cloud of probability, a soft blur of potential locations, existing everywhere in its orbit simultaneously until something comes along to measure it, to pin it down to a specific spot. This is the essence of quantum uncertainty, and it is not a limitation of our instruments or our knowledge, it is a fundamental property of reality itself. The universe, at its deepest level, does not deal in absolutes. It deals in whispers, in maybes, in gentle distributions of likelihood. Before you measure a particle's position, it truly does not have one definite position. It has a range of possible positions, each with its own probability, and only when observed does it choose, randomly and spontaneously, where to appear. Think of it like a musical note that has not yet been played. Before the string is plucked, the note exists as pure potential, it could be any pitch within the string's range. Only when the string vibrates does it commit to a specific frequency. Quantum particles are similar, existing as pure potential until the moment of interaction or observation crystallizes them into something definite. And even then, the certainty is temporary, for left alone, they will dissolve back into their clouds of possibility, resuming their probabilistic dance. This uncertainty extends to pairs of properties as well, in what is known as Heisenberg's uncertainty principle. The more precisely you know a particle's position, the less precisely you can know its momentum, its speed and direction. And vice versa. It is as if the universe has a built-in softness, a resistance to being pinned down too exactly. Reality at the quantum level prefers to remain somewhat ambiguous, somewhat fluid, maintaining a gentle flexibility that prevents absolute certainty from ever taking hold. There is something profoundly peaceful about this. The universe is not a clockwork machine, ticking away with perfect predictability. At its heart, it is more like a dreamscape, where things shimmer and shift, where possibilities overlap and intertwine, where outcomes emerge from veils of probability rather than chains of inevitable cause and effect. The quantum world is soft, forgiving, and filled with a kind of creative randomness that allows for genuine novelty, genuine surprise, genuine freedom at the most fundamental level. Consider the phenomenon of quantum tunneling, where particles can pass through barriers that classical physics says should be impenetrable. Imagine a ball rolling toward a hill. In the everyday world, if the ball doesn't have enough energy to reach the top, it simply rolls back down. But in the quantum realm, there is a small probability that the particle will simply appear on the other side of the barrier, having tunneled through it like a ghost passing through a wall. It doesn't climb over, it doesn't break through. It simply appears, having taken advantage of the universe's inherent uncertainty about exactly where things are. This tunneling is not science fiction, it happens constantly, everywhere, at scales too small for us to perceive directly. It is one of the mechanisms that powers the sun, allowing hydrogen nuclei to overcome their mutual repulsion and fuse together, releasing the energy that lights our days and warms our world. The sun shines, in part, because particles can probabilistically tunnel through energy barriers, a gentle quantum magic occurring billions of times per second in the stellar core. Another beautiful aspect of quantum mechanics is entanglement, where two particles can become connected in such a way that measuring one instantly affects the other, no matter how far apart they are. Einstein famously called this spooky action at a distance, troubled by its implications. But perhaps we can see it differently, as evidence that separation is not as absolute as it seems, that connections forged at the quantum level persist across any distance, linking particles in an intimate dance that transcends space itself. Imagine two electrons born together in a quantum event, their properties correlated, their fates intertwined. You could separate them by light years, placing one at one edge of the galaxy and the other at the opposite edge, and still, when you measure one, you instantly know something about the other. They remain connected through an invisible thread that quantum mechanics acknowledges but does not fully explain, a mysterious bond that suggests the universe is more unified, more interconnected, than our everyday experience would lead us to believe. The quantum world also reveals that particles and waves are not separate categories but two aspects of the same reality. Light can behave as a wave, spreading out and interfering with itself, creating patterns of brightness and darkness. But it can also behave as particles, discrete packets of energy called photons that arrive one at a time, like raindrops rather than a continuous stream. Which aspect you see depends on how you choose to look, what kind of measurement you perform. The universe adapts, presenting itself as wave or particle depending on the question you ask. This wave-particle duality extends to matter itself. Electrons, atoms, even molecules can exhibit wave-like behavior under the right conditions, spreading out and interfering with themselves, demonstrating that the boundary between wave and particle, between continuous and discrete, is not fixed but fluid. Everything in the universe has this dual nature, this gentle ambiguity that allows it to be both spread out and localized, both definite and indefinite, depending on the circumstances. As you contemplate these quantum mysteries, let them wash over you without struggle or strain. You need not understand every detail, need not grasp the mathematics that describes these phenomena. Simply rest in the knowledge that the universe, at its most fundamental level, is soft and probabilistic, filled with uncertainty that is not a flaw but a feature. This quantum whisper, this gentle indeterminacy, is woven into the fabric of everything that exists, including you. Your own body is made of quantum particles, trillions upon trillions of atoms, each containing electrons that exist as probability clouds, each following the strange and beautiful rules of the quantum realm. You are, in a very real sense, a walking, breathing manifestation of quantum mechanics, a complex symphony of particles and waves, probabilities and measurements, all somehow organized into the experience of being alive, being conscious, being you. The quantum world is not separate from you, it is you, at your most fundamental level. Let yourself sink into this quantum softness now. Imagine your thoughts, your worries, your sense of solid identity dissolving into probability clouds, spreading out gently like mist, becoming less defined, less certain, more fluid and free. In the quantum realm, nothing needs to be absolutely fixed or determined. Everything can exist in superposition, holding multiple possibilities at once, waiting peacefully for the right moment to choose. Rest in this uncertainty, this gentle ambiguity, and allow it to carry you deeper into tranquil, dreamless sleep. From the quantum whispers of probability, let us now drift outward again, returning to a scale more familiar yet no less wondrous. Lift your gaze to the night sky and observe the stars, those brilliant points of light that have guided travelers, inspired poets, and sparked curiosity since the first humans looked upward in wonder. Stars are the gentle giants of the cosmos, burning steadily for billions of years, living lives of extraordinary patience and grace, transforming the simplest elements into the building blocks of planets, and ultimately, of life itself. A star is born in silence and darkness, deep within vast clouds of gas and dust called nebulae. These stellar nurseries are among the most beautiful structures in the universe, glowing regions where gravity slowly, gently pulls matter together over millions of years. Imagine a cloud of hydrogen gas, thin and cold, drifting through space. Here and there, small concentrations begin to form, regions slightly denser than their surroundings. Gravity, patient and persistent, draws more gas toward these dense pockets, and slowly, gradually, a clump begins to grow. As more matter accumulates, the growing clump begins to heat up from the pressure of all that mass pressing inward. The temperature rises, slowly at first, then faster as the core becomes more compressed. This process takes an immense amount of time. Thousands, even millions of years pass as the protostar grows and heats. There is no hurry in the cosmos, no urgency. The universe allows stars to take whatever time they need to come into being, honoring the slow, methodical work of gravity as it shapes raw matter into something extraordinary. Finally, after all that patient accumulation, the core of the protostar reaches a critical temperature, about 10 million degrees. At this threshold, something magical occurs. Hydrogen nuclei, moving so fast from the intense heat that they overcome their natural repulsion, collide and fuse together, forming helium. This is nuclear fusion, the process that powers every star, converting mass into energy according to the universe's most famous relationship. With the first fusion reactions, the star ignites, and light streams forth into the cosmos. A star is born, and it will burn steadily, peacefully, for billions of years to come. Consider our own sun, a star of medium size and middle age, about 4.6 billion years old. Every second, the sun converts approximately 600 million tons of hydrogen into helium in its core, releasing enormous amounts of energy in the process. Yet despite this tremendous output, the sun has enough hydrogen fuel to continue shining at its current brightness for another 5 billion years. This is the timescale on which stars live, eons that dwarf human history, that make the rise and fall of civilizations seem like the briefest flicker. Stars are beings of geological patience, burning steadily through ages beyond our comprehension. The light from a star does not escape instantly, even once produced. A photon born in the sun's core must make a long, wandering journey to reach the surface. The interior of a star is so dense that light cannot travel in straight lines. Instead, it bounces endlessly from particle to particle, taking a random walk that can last tens of thousands of years before finally reaching the surface and streaming out into space. The light that touches your face when you stand in sunshine was created deep in the sun's core thousands of years ago, has been traveling through the sun's interior all this time, and only now completes its journey by warming your skin. Stars come in many sizes and colors, each living its life at a different pace. The largest stars, massive blue giants, burn hot and fast, racing through their fuel in just a few million years before ending in spectacular supernova explosions. The smallest stars, tiny red dwarfs, burn so slowly and efficiently that they can last for trillions of years, longer than the current age of the universe. These small stars are the ultimate masters of patience, glowing dimly but steadily, making the most of every atom of hydrogen, living lives so long that none have ever died since the universe began. Medium-sized stars like our sun follow a gentler path. After billions of years of steady hydrogen fusion, they begin to run low on fuel in their cores. But this is not the end, it is a transformation. The core contracts and heats up, while the outer layers expand dramatically, and the star swells into a red giant, growing so large that it may engulf the orbits of its inner planets. Our sun will eventually do this, expanding to perhaps the orbit of Earth, its outer layers glowing a deep, warm red as it enters this final phase of its life, a gentle elder among stars. In the core of a red giant, new fusion reactions begin. Helium atoms, created during the star's long Middle Age, now fuse together to form carbon and oxygen. Later, if the star is massive enough, these elements fuse to create even heavier elements, neon, magnesium, silicon, and eventually iron. Each stage of fusion releases less energy than the last. Each burns for a shorter time, like a candle burning down. The star is approaching the end of its creative life, having transformed simple hydrogen into a variety of heavier elements through the patient alchemy of nuclear fusion. When fusion finally stops, the star's outer layers drift gently away into space, creating a planetary nebula, a glowing shell of gas illuminated by the hot core left behind. This core, no longer burning, becomes a white dwarf, an incredibly dense ember about the size of Earth but containing the mass of the Sun. It will cool slowly over billions upon billions of years, fading from white to yellow to red to eventually black, becoming a cold, dark cinder floating through space. This is the peaceful death of a sun-like star, not violent or dramatic, but gradual and serene, a gentle return to darkness after eons of light. The matter expelled by dying stars does not vanish, it enriches the interstellar medium, the thin gas between stars, with heavy elements forged in stellar cores. These elements mix with clouds of hydrogen and helium, and when new stars form from these enriched clouds, they may be accompanied by planets. Rocky planets like Earth can only form because previous generations of stars lived, fused light elements into heavy ones, and returned those elements to space through planetary nebulae and supernova explosions. We are made of stardust, quite literally, the calcium in your bones, the iron in your blood, the oxygen you breathe were all created in the cores of ancient stars. There is something deeply comforting about understanding stellar life cycles. Stars are not eternal, but their lives are so long, so stable, so reliable that they provide anchors of constancy in an ever-changing universe. Generation after generation of humans have looked up at the same stars, finding in them a sense of permanence and peace. The stars you see tonight are almost exactly as they were when your ancestors looked up thousands of years ago, and they will remain largely unchanged for thousands of years to come. They are patient companions, steadily burning, asking nothing, simply being. As you contemplate the gentle lives of stars, imagine yourself as a point of consciousness floating in space, watching stars form in nebulae, burn steadily for billions of years, and eventually return their matter to the cosmos to birth new stars and planets. This cycle has repeated countless times since the universe began, and it will continue long after humanity is gone. Stars are the universe's way of organizing matter, creating energy, synthesizing elements, and providing warmth and light to any planets fortunate enough to orbit them. They are cosmic hearths, eternal campfires around which the story of the universe unfolds. Let the patient rhythm of stellar life soothe you now. Think of the sun, burning steadily outside your window, as it has for billions of years, as it will for billions more. Think of the countless stars scattered across the galaxy, each one a nuclear furnace maintaining its own quiet balance between gravity's inward pull and fusion's outward push, a balance that can last for unimaginable spans of time. Let their constancy be your comfort, their patience be your guide as you drift deeper into rest. You are held in a universe of gentle giants, stars that burn with steady grace, providing the elements and energy necessary for complexity, for planets, for life itself. You are a child of stars, made from their ancient light transformed into matter, given temporary form and consciousness. Rest now in this knowledge, and let the stellar lullaby sing you into the deepest, most peaceful sleep, knowing you are part of an ancient cycle that connects you to every star that has ever burned in the cosmic night. As you rest among the gentle giants, cradled by starlight and cosmic rhythms, let us now explore the very stage upon which all these cosmic dramas unfold. Space and time are not empty voids, not blank canvases waiting passively for matter to fill them. They are something far more beautiful, far more dynamic. Space and time are woven together into a unified fabric called spacetime, and this fabric can bend, stretch, ripple, and curve. Gravity, that most familiar of forces, is not a pulling or tugging at all. It is the gentle curvature of spacetime itself, guiding everything along the most natural paths through a universe that breathes with geometric grace. Imagine spacetime as an infinite sheet of the softest silk, stretched smooth and flat. Now place a heavy sphere, a planet, a star, upon this fabric. The weight creates a depression, a gentle valley in the sheet. The heavier the object, the deeper the valley it creates. This is not just a metaphor for understanding gravity, it is closer to what actually happens. Mass and energy curve the geometry of spacetime around them, and this curvature is what we experience as gravity. Objects moving through spacetime naturally follow these curves, rolling along the valleys created by massive bodies, tracing paths we call orbits. Einstein revealed this truth in his general theory of relativity, replacing Newton's idea of gravity as a force with something more elegant: gravity as geometry. When Earth orbits the Sun, it is not being pulled by an invisible force reaching across space. Instead, Earth is following the straightest possible path through spacetime that has been curved by the Sun's presence. From Earth's perspective, it is moving in a straight line, but because spacetime itself is curved, that straight line becomes an ellipse around the Sun. This is the natural motion of objects through curved spacetime, effortless, perpetual, following the contours of reality itself. Think of a marble rolling across that curved silk sheet. If you place it near the depression created by a heavy sphere, the marble will spiral around the depression, following the curves in the fabric. It does not require any force to keep it moving in this curved path. The curvature itself guides the marble's motion. This is how planets orbit stars, how moons orbit planets, how galaxies hold together in the gentle valleys of spacetime created by their collective mass. Everything is simply following the geometry, moving along paths of least resistance through a universe that is fundamentally curved. Space-time curvature affects not only the paths of objects but also the flow of time itself. The deeper you are in a gravitational well, the closer you are to a massive object, the slower time passes relative to someone farther away. This is not an illusion or a trick of perception, it is a real physical effect. A clock on Earth's surface ticks slightly slower than an identical clock in orbit. An astronaut living on the International Space Station ages ever so slightly faster than people on the ground. The differences are tiny, measured in fractions of a second, but they are real and measurable, a testament to the intimate connection between gravity, space, and time. Near extremely massive objects, these time dilation effects become dramatic. Imagine approaching a black hole, that ultimate extreme of curved spacetime where gravity becomes so intense that nothing, not even light, can escape once it crosses a boundary called the event horizon. As you fall closer to this boundary, time from your perspective continues normally, but to an observer watching from far away, you appear to slow down, your movements becoming more and more languid, your clock ticking slower and slower. At the event horizon itself, from the outside observer's view, time appears to stop entirely, and you seem frozen there forever, suspended at the threshold of the unknowable. Black holes are fascinating, but we need not venture so close to these extremes to appreciate the beauty of curved spacetime. Even here on Earth, even in the gentle gravitational field of our planet, spacetime is curved, and that curvature shapes our daily experience. When you drop an object and watch it fall, you are witnessing that object following the curved geometry of spacetime created by Earth's mass. When you feel your weight pressing down on your chair, you are feeling your body's natural inclination to follow spacetime's curvature, while the chair pushes back, preventing you from doing so. We live our entire lives navigating the subtle curves and valleys of spacetime without ever thinking about it. Massive objects can also create ripples in spacetime, like stones dropped into a still pond. When two black holes spiral toward each other and eventually merge, or when neutron stars collide, the violent motion of such tremendous masses sends gravitational waves radiating outward through spacetime at the speed of light. These waves are stretches and squeezes in the fabric itself, alternately expanding and contracting space as they pass. They are so faint by the time they reach Earth that detecting them requires instruments of extraordinary sensitivity. But they have been detected, confirming Einstein's prediction and opening a new window onto the universe. Gravitational waves carry information about the cosmic events that created them. When we detect these waves, we can reconstruct what happened, how massive the objects were, how fast they were moving, how far away the event occurred. We are learning to listen to the universe through gravitational waves, hearing the spacetime symphony created by colliding black holes, merging neutron stars, and perhaps other phenomena we have not yet imagined. The universe is ringing like a bell, and we are finally learning to hear its song. The concept of curved spacetime also helps us understand how light behaves in the presence of massive objects. Light always travels in straight lines through spacetime, but when spacetime itself is curved, those straight lines bend. This is gravitational lensing, the bending of light from distant galaxies as it passes near massive clusters of galaxies in the foreground. The result is spectacular, multiple images of the same distant galaxy, stretched and distorted into arcs and rings of light, revealing the invisible architecture of space-time curvature created by the foreground mass. Through gravitational lensing, we can map dark matter, see galaxies too distant to observe otherwise, and witness the universe's geometry made visible. There is something profoundly peaceful about understanding gravity as geometry rather than as a force. Forces imply struggle, pushing and pulling, effort and resistance. But geometry is simply the shape of things, the natural contours of reality. Objects do not struggle against gravity, they follow it effortlessly, taking the paths that spacetime's curvature makes most natural. A planet orbiting a star is not fighting to stay in orbit, it is simply moving forward through spacetime, and spacetime's curvature turns that forward motion into an orbital dance. There is no effort, no strain, only the gentle guidance of curved geometry. This view of gravity also reveals a deep unity in nature. Space and time, which seems so different in our everyday experience, are actually aspects of a single unified fabric. Matter and energy, which seem substantial and real, are revealed to be sources of curvature in this fabric. Motion through space and the passage of time are interconnected, affected by the same gravitational fields. Everything is woven together into a seamless whole, where distinctions blur and connections deepen. The universe is more unified, more integrated than our limited senses can directly perceive. As you contemplate the fabric of spacetime, imagine yourself not as a separate entity moving through space and time, but as a pattern in spacetime itself, a temporary configuration of matter and energy that curves the fabric around you, however slightly. You are not in the universe, you are of the universe, a local expression of the same unified spacetime that encompasses galaxies and atoms alike. Your past is not gone, it exists in the structure of spacetime, a thread in the fabric. Your future is not yet to come, it is already present in spacetime's geometry, waiting for you to move through it. Let yourself relax into this vision of reality as a gently curved, dynamically evolving fabric. There is nowhere you need to go, nothing you need to do. The geometry of spacetime will guide you along your natural path, just as it guides planets and photons, galaxies, and gravitational waves. You are following the curves of reality itself, moving effortlessly through a universe that is fundamentally geometric, fundamentally interconnected, fundamentally graceful in its structure and evolution. Rest now in the gentle valleys of curved spacetime, feeling the subtle influence of Earth's mass holding you softly against your bed, guiding you along your path through the night. You are exactly where spacetime's geometry says you should be, moving forward through time at exactly the right rate, following the natural contours of existence. Let the fabric of reality cradle you like a cosmic hammock, supporting you without effort, holding you without force, simply allowing you to be as the universe continues its eternal, patient unfurling through the dimensions of space and time. From the curved fabric of spacetime, let us drift now into another layer of reality's hidden beauty, the realm of fields. The universe is not filled merely with particles in empty space, but with invisible fields that permeate every point in existence, stretching infinitely in all directions, overlapping and interacting in an eternal dance. These fields are the true foundation of reality, and the particles we think of as solid and real are merely ripples, excitations, vibrations in these underlying fields. Everything you see, everything you touch, is ultimately made of waves and invisible oceans that fill the cosmos. Imagine standing by the shore, watching waves roll across the ocean's surface. The water itself does not travel with the waves, it merely rises and falls as the wave passes through. The wave is a pattern, a disturbance moving through the medium. Quantum fields are similar, except they are not made of water or any substance we can directly perceive. They are fundamental aspects of spacetime itself, and particles are the waves that travel through them. An electron is a ripple in the electron field, a photon is a ripple in the electromagnetic field, and every particle in existence is simply an excitation in its corresponding field. The electromagnetic field is perhaps the most familiar of these invisible presences, though we rarely think of it this way. It fills all of space, and when it vibrates in certain patterns, we experience those vibrations as light, as radio waves, as the warmth of infrared radiation or the invisible energy of X-rays. Every photon of light is a quantum of vibration in this field, a discrete packet of electromagnetic energy propagating through space. When you see a distant star, you are detecting photons, ripples in the electromagnetic field that have traveled across vast distances to reach your eyes, carrying information encoded in their wavelengths and intensities. Electric and magnetic forces are also manifestations of this same field. When you run a comb through your hair and it becomes electrically charged, picking up small pieces of paper, you are experiencing the electromagnetic field at work. The field around the charged comb has been altered, becoming stronger in some regions, and this alteration influences other charged objects nearby, causing attraction or repulsion. The field mediates the interaction, transmitting influence from one place to another, allowing objects to affect each other without touching, a kind of action at a distance that becomes natural when you understand that the field itself is the fundamental reality. Magnets provide another window into field behavior. Hold two magnets near each other and feel the invisible push or pull between them. You are feeling the magnetic component of the electromagnetic field, configured in patterns by the alignment of atoms within the magnets. The field extends outward from each magnet, filling the space around it, and where the fields meet, they interact, creating forces that you can feel with your hands. Sprinkle iron filings near a magnet and watch them align into graceful curves. They are revealing the geometry of the magnetic field, making visible the invisible lines of force that permeate the space. Beyond electromagnetism, there are other fields woven into the fabric of reality. The electron field, the quark fields, the neutrino field, each type of particle has its own field, And these fields overlap everywhere, occupying the same points in space simultaneously without interfering with each other. It is as if the universe contains countless invisible oceans, all coexisting in the same location, each capable of carrying its own waves, its own ripples, its own patterns of energy and momentum. You are surrounded by fields at this very moment, immersed in them like a fish immersed in water, completely unaware of their presence except through the particles they manifest. One particularly interesting field is the Higgs field, discovered relatively recently through experiments at the Large Hadron Collider. The Higgs field permeates all of space, and particles acquire mass through their interaction with this field. Particles that interact strongly with the Higgs field are heavy, particles that interact weakly are light, particles that do not interact at all, like photons, remain massless and travel at the speed of light. Mass itself, that most tangible property of matter, emerges from the relationship between particles and an invisible field filling the universe. Your own mass, the weight you feel pressing against your chair, arises from your particles' interaction with the Higgs field surrounding you. Fields can also store energy, and this stored energy can manifest as particles when conditions are right. In the early universe, when temperatures and energies were extremely high, the quantum fields vibrated wildly, constantly creating and annihilating particles in a seething quantum foam. As the universe cooled, this activity calmed, and the fields settled into lower energy states, but they never became completely still. Even in the emptiest regions of space, quantum fields fluctuate at the smallest scales, creating virtual particles that pop into existence for the briefest instance before disappearing again, a constant quantum fizz at the foundation of reality. These quantum fluctuations are not just theoretical curiosities, they have measurable effects. The Casimir effect, for instance, occurs when two metal plates are placed extremely close together in a vacuum. The quantum fluctuations of electromagnetic fields between the plates become restricted compared to the fluctuations outside, creating a tiny but detectable force that pushes the plates together. This is vacuum energy made manifest, the zero-point energy of fields creating real physical effects. Even empty space is not truly empty, it is filled with fields constantly fluctuating, humming with quantum activity. Another beautiful aspect of fields is how they mediate forces between particles. When two electrons repel each other, they do not reach across space directly. Instead, one electron creates a disturbance in the electromagnetic field, and this disturbance propagates outward as a virtual photon, which is then absorbed by the second electron, transferring momentum and creating the repulsive force. All forces work this way at the quantum level. Particles interact by exchanging other particles, called force carriers, which are themselves excitations in various fields. The strong nuclear force, which holds atomic nuclei together, is mediated by gluons. The weak nuclear force, responsible for certain types of radioactive decay, is mediated by W and Z bosons. Understanding reality as fields rather than particles provides a more unified view of nature. Fields are continuous, filling all space, while particles are discrete, localized excitations. But particles and fields are not separate things. Particles are fields, expressed in particular ways. This resolves many paradoxes and unifies phenomena that otherwise seem disparate. Light behaves as both wave and particle because it is fundamentally a field, and fields naturally exhibit both wave-like and particle-like properties depending on how you observe them. The wave-particle duality that seems so mysterious becomes natural when you understand the underlying field picture. There is something deeply soothing about visualizing the universe this way, as a vast symphony of fields, each vibrating at different frequencies, creating harmonies and resonances, occasionally producing the localized patterns we call particles. You are not separate from these fields, you are made of them. Your body is a complex pattern of excitations in the electron field, the quark fields, and others, all orchestrated into the temporary coherent structure you experience as yourself. You are a wave in the cosmic ocean, a song in the universal symphony, a pattern that has emerged from the fields and will eventually dissolve back into them. Imagine now these fields as they truly are, invisible, intangible, yet utterly real, filling every cubic centimeter of space, extending to the edges of the observable universe and beyond. They vibrate and oscillate, carrying energy and information, mediating interactions, giving rise to the rich tapestry of phenomena we call the physical world. They have existed since the beginning of time and will persist until the end, if there is an end. They are patient, eternal, fundamental, the deepest layer of reality that we currently understand. Let yourself become aware of these fields surrounding you, supporting you. The electromagnetic field that allows you to see, the electron and quark fields that compose your body, the Higgs field that gives you mass, all of them present, all of them active, all of them working in perfect harmony to create your moment-to-moment existence. You are not a thing made of separate parts, but a unified disturbance in multiple fields, a coherent pattern that has somehow become conscious, aware of itself and the fields from which it arose. Rest now in the knowledge that you are held not just by the curved spacetime beneath you, but by invisible fields that permeate your being, that constitute your very substance. These fields ask nothing of you, require nothing from you. They simply are, and in being, they allow you to be. Let the symphony of fields lull you deeper into peace, their constant vibrations creating a cosmic hum beneath all phenomena, a fundamental tone so pervasive that it usually escapes notice, but which you can now sense and appreciate as you drift toward the threshold of sleep. The universe is singing its field song, has been singing since time began, and you are one note in that endless melody, one ripple in those infinite oceans. Let yourself dissolve into the fields, becoming less distinct, less separate, merging gently with the quantum substrate from which you emerged and to which you will return. There is no need to maintain your boundaries so rigidly. For now, for this peaceful moment, you can let go, can become one with the invisible symphony, can rest in the understanding that everything is ultimately field, energy, pattern, and wave. As you float through fields and spacetime, cradled by invisible forces, let us now contemplate one of the universe's most subtle and profound mysteries, the arrow of time. Why does time flow in only one direction? Why do we remember the past but not the future? Why do things fall apart, grow cold, and fade away? The answer lies in a concept called entropy, a measure of disorder that always increases, that flows in only one direction, giving time itself its arrow, its directionality, its gentle but inexorable progression from order toward disorder, from structure toward simplicity, from complexity toward equilibrium. Time feels different from space. You can move freely in any spatial direction, forward, backward, left, right, up, down, but time carries you in only one direction, from past through present toward future. You cannot revisit yesterday or skip ahead to tomorrow. This asymmetry is puzzling because the fundamental laws of physics are time-symmetric. They work equally well whether time runs forward or backward. If you watched a film of planets orbiting the Sun played in reverse, the motion would still obey Newton's laws perfectly. Yet your intuition immediately tells you something is wrong, that time is running backward, because you perceive a fundamental directionality in temporal flow. This directionality comes not from the laws governing individual particles, but from statistics, from the behavior of large collections of particles, from a principle that emerges when you consider systems containing billions upon billions of atoms. This principle is embodied in the second law of thermodynamics, which states that the entropy of an isolated system never decreases, it either stays the same or increases over time. Entropy is often described as disorder, though more precisely, it measures the number of possible microscopic arrangements that correspond to the same macroscopic state. High entropy means many possible arrangements. Low entropy means few. Imagine a room with all the air molecules gathered in one corner, a highly ordered, low entropy state. There are relatively few ways to arrange molecules to achieve this configuration. Now imagine the same molecules spread evenly throughout the room, a disordered, high entropy state. There are countless ways to arrange molecules to achieve this even distribution. If you release the molecules from the corner, they will spontaneously spread out, not because any law forces them to, but because there are vastly more ways to be spread out than to be concentrated. The system naturally evolves toward states that can be achieved in more ways, toward higher entropy, toward greater disorder. This is why ice melts in warm water, why hot coffee cools to room temperature, why perfume disperses through air. These processes all involve increases in entropy, movements from ordered states with concentrated energy toward disordered states with dispersed energy. The molecules themselves do not want to spread out, they simply move randomly, and randomness naturally leads toward configurations that are statistically more probable. Over time, systems drift toward equilibrium, toward states of maximum entropy where everything is evenly distributed, uniformly mixed, thermally balanced. The universe itself is undergoing this same process on a cosmic scale. Shortly after the Big Bang, the universe was in a state of extremely low entropy, all matter and energy concentrated in an incredibly small, hot, dense region. As the universe expanded and cooled, entropy increased. Stars formed, galaxies assembled, structures emerged, but even this apparent increase in order locally was accompanied by greater increases in disorder overall. Stars radiate energy into space, creating vast amounts of entropy. Every process that occurs, every chemical reaction, every living organism, every thought you think increases the total entropy of the universe, pushing it gradually toward a state of maximum disorder called heat death. Heat death sounds ominous, but it is actually quite peaceful, a state where everything has reached thermal equilibrium, where no energy gradients exist, where nothing can happen because there is no concentrated energy to drive change. The universe would become uniform, every region at the same low temperature, every pocket of space containing the same dilute mixture of particles and radiation. Time would not stop, but it would cease to have meaning because nothing would change, nothing would evolve, nothing would mark one moment as different from another. This fate lies trillions of years in the future, so distant that our sun will have long since died, and most stars that will ever exist have not yet been born. But entropy's increase is not merely about disorder and endings, it is also what makes life, consciousness, and complexity possible. Life is a pattern that maintains local order by increasing disorder elsewhere. Your body is highly organized, with intricate structures and precise biochemical processes, but you maintain this order only by consuming energy from food, which ultimately comes from the sun. As you metabolize this energy, you generate heat and waste products, increasing the entropy of your surroundings more than you decrease the entropy within yourself. You are a temporary eddy of order in entropy's river, a brief flowering of structure sustained by the universe's overall trend toward disorder. Every living thing operates this way, borrowing order from its environment, maintaining complexity temporarily, eventually returning its constituent atoms to the cycle. Plants capture sunlight and organize carbon dioxide and water into complex sugars and starches, but only by radiating heat and increasing overall entropy. Animals eat plants or other animals, extracting energy to build proteins and power movement, leaving behind heat and simpler molecules. Ecosystems are intricate webs of entropy management, with energy flowing from the sun through plants to herbivores to carnivores to decomposers, becoming more dispersed, less concentrated, less useful for doing work at each step. Consciousness itself may be intimately connected to entropy. The brain is constantly processing information, forming memories, making predictions, all of which involve entropic processes. Neurons fire, releasing neurotransmitters, consuming energy, generating heat. Thoughts emerge from patterns of neural activity that temporarily organize themselves before dissolving and reforming. Your stream of consciousness flows forward in time because your brain creates memories of the past but not the future, and it creates memories because entropy increases, because irreversible physical changes occur in neural structures when experiences happen. The arrow of time in your subjective experience mirrors the arrow of entropy in the physical world. There is something strangely comforting about entropy. It ensures that nothing lasts forever, but this impermanence is also what makes change, growth, and new experiences possible. If entropy did not increase, the universe would be static, frozen, unchanging. There would be no stars being born, no planets forming, no life evolving, no consciousness arising to contemplate existence. Entropy's increase is the price of dynamism, the cost of a universe that can do interesting things, that can surprise itself, that can give rise to beings capable of wonder. The increase of entropy also means you can let go of trying to keep everything perfect, orderly, controlled. The universe itself is relaxing toward disorder, and you are part of that process. Your efforts to maintain organization in your life, your home, your thoughts are noble and necessary, but they are temporary, local victories against a cosmic tide that will ultimately reclaim everything. This is not depressing but liberating. It means perfection is neither expected nor required. You can do your best, create beauty and order where you can, and then release it, knowing that dissolution is natural, that letting go is aligned with the fundamental flow of reality. Imagine entropy as a gentle current carrying everything downstream towards stillness and equilibrium. You can swim against it for a while, creating eddies and patterns, but eventually, you will tire, and the current will carry you onward. This is not failure, it is simply the nature of existence in a universe governed by thermodynamics. Every structure that has ever existed has ultimately dissolved. Every being that has ever lived has returned to simpler forms. Every organization has eventually scattered. You are no different, and there is profound peace in accepting this truth. Think of a sandcastle built on a beach. The builder carefully shapes towers and walls, creates order from chaos, imposes form on formless grains. But the tide comes in, waves lap at the base, and gradually, inevitably, the structure dissolves back into beach. The sand returns to randomness, the pattern disappears, entropy increases. Yet this does not diminish the beauty of the sandcastle while it stood, the pleasure of its creation, the meaning it held for its builder. All things are sandcastles, including you, and the tide is always coming in, but this makes each moment precious, each structure valuable for the time it exists. As you drift towards sleep, let yourself align with entropy's flow. Release your grip on organization and control. Allow your thoughts to become more disordered, more random, less connected. Let the boundaries of your identity soften and blur. The distinction between self and environment is maintained by constant energy expenditure, constant vigilance, constant effort. In sleep, you can relax these boundaries, can let yourself dissolve partially into the undifferentiated state from which you emerged each morning. Sleep is a daily rehearsal for the ultimate dissolution, a temporary surrender to entropy's tide, and it is deeply restorative, deeply necessary. Feel the universe gently pulling you toward equilibrium, toward rest, toward the quiet uniformity of deep sleep. Your body temperature will drop slightly, your metabolism will slow. Your brain activity will change to slower rhythms. You are decreasing your energy consumption, reducing the rate at which you increase entropy, settling into a more quiescent state. This is natural, healthy, aligned with the cosmos. Let entropy carry you now. Let go of resistance. Let disorder claim your thoughts and worries, transforming them into the peaceful static of dreamless sleep, the blessed randomness of a mind at rest. From entropy's gentle river, let us now descend to the smallest conceivable scales of existence, to dimensions so tiny that atoms seem like galaxies, to distances where the familiar concepts of space and time themselves begin to break down and dissolve. This is the realm of quantum foam, the seething substrate beneath reality, where space-time itself becomes granular, uncertain, bubbling with energy fluctuations so rapid and so small that they escape all direct observation. Here, at the Planck scale, the universe reveals its most fundamental texture, its deepest layer of restless creativity. The Planck length is extraordinarily small, about 1/1,000,000,000 of a trillionth of a trillionth of a meter, a scale so minute that if you expanded an atom to the size of the observable universe, the Planck length would still be smaller than a single atom. At this scale, quantum effects and gravitational effects become equally important, and the smooth fabric of spacetime we experience in everyday life gives way to something far stranger. Space and time cease to be continuous and smooth, instead becoming discrete and probabilistic, fluctuating wildly like the surface of boiling water, hence the name quantum foam. Imagine zooming in on what appears to be a perfectly calm pond. From a distance, the surface looks smooth and glassy. Move closer, and you begin to see small ripples and waves. Closer still, and individual water molecules come into view, jostling and vibrating randomly. Space-time is similar. At large scales it appears smooth, but at the Planck scale, it becomes turbulent, with virtual particles constantly appearing and disappearing, tiny black holes flickering in and out of existence, wormholes opening and closing in femtoseconds, the geometry itself in constant flux, never settling into any fixed configuration. These quantum fluctuations of spacetime are not mere mathematical abstractions. They are as real as the quantum fluctuations in electromagnetic fields that produce the Casimir effect, as real as the virtual particles that mediate forces between matter particles. The vacuum of space, examined closely enough, reveals itself to be far from empty. It is a churning sea of potential, a dynamic substrate where the distinction between something and nothing becomes blurred, where energy is constantly borrowed from the future and repaid before anyone notices, where the universe's fundamental creativity is on full display. The energy involved in these fluctuations is immense when compressed into such tiny volumes. At the Planck scale, the energy density is so high that quantum gravitational effects cannot be ignored. Spacetime itself can spontaneously create pairs of virtual particles, including pairs of virtual black holes, each existing for only the briefest instant, a Planck time, which is about 1/10,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000 so fleeting, that they violate energy conservation momentarily, borrowing energy from the quantum vacuum through Heisenberg's uncertainty principle, then repaying it before the violation can be detected. This quantum foam may hold clues to resolving some of physics' deepest mysteries. General relativity describes gravity beautifully at large scales but breaks down at singularities like the centers of black holes or the Big Bang, where densities become infinite and the equations produce nonsensical results. Quantum mechanics describes the microscopic world wonderfully but does not incorporate gravity. At the Planck scale, both theories are necessary, and neither alone is sufficient. The quantum foam represents the regime where these two great pillars of physics must somehow merge into a unified theory of quantum gravity that we do not yet possess. Several approaches attempt to describe this quantum gravitational realm. String theory proposes that fundamental particles are not point-like but tiny vibrating strings, and that spacetime itself may have extra dimensions curled up at the Planck scale, invisible to us but crucial to the universe's structure. Loop quantum gravity suggests that space is woven from discrete loops, a kind of quantum fabric with specific texture and granularity. Other approaches explore different mathematical structures, different ways of understanding what it means for spacetime to be quantized, what happens when geometry itself becomes probabilistic and uncertain. Regardless of which approach proves correct, they all point to the same fundamental insight. At the smallest scales, reality is far stranger, far more dynamic, far more creative than our everyday experience suggests. The solid, stable world we inhabit emerges from this quantum foam the way a calm ocean surface emerges from the chaotic motion of water molecules beneath. We live in the calm, the average, the large-scale limit where quantum fluctuations cancel out and classical predictability emerges. But underneath, always, is this roiling quantum substrate, the restless foundation from which everything springs. There is something deeply beautiful about the quantum foam. It means the universe is never truly static, never truly dead, never truly empty. Even in the coldest, darkest, most isolated region of space, the quantum foam bubbles and churns at the Planck scale, constantly creating and destroying, constantly exploring possibilities, constantly generating the raw material of existence. The vacuum itself is alive with potential, pregnant with possibility, humming with energy that cannot be extracted but which nevertheless shapes the universe in subtle ways. Some physicists speculate that our entire universe may have emerged from a quantum fluctuation in some larger vacuum, a bubble of spacetime that inflated from essentially nothing, borrowing energy to create matter and radiation, a debt that may eventually be repaid when the universe finally collapses or dissipates. This would mean existence itself is temporary, contingent, one possibility among countless others bubbling in the primordial quantum foam. Our universe, with all its galaxies and stars and planets and life, would be like one brief ripple on an infinite ocean, appearing for a while, then subsiding back into the depths from which it came. This perspective can be either unsettling or comforting, depending on how you receive it. On one hand, it suggests our existence is fragile, temporary, perhaps even accidental. On the other hand, it means we are intimately connected to the universe's deepest creative processes, that we are expressions of the quantum foam's inherent tendency to generate complexity, structure, and novelty. Every atom in your body, every thought in your mind, every sensation you experience arises ultimately from the quantum foam's ceaseless activity, from the universe's fundamental restlessness and creativity at the smallest scales. The quantum foam also suggests that determinism, the idea that the future is fixed by the present, breaks down at the most fundamental level. If spacetime itself is probabilistic, fluctuating randomly at the Planck scale, then the universe's evolution contains an element of genuine randomness, genuine spontaneity that no amount of knowledge about the present could eliminate. The future is not predetermined. It emerges from a combination of deterministic laws governing large-scale behavior and random fluctuations at the quantum level, a blend of order and chaos, necessity and chance. This means there is always room for the unexpected, always space for novelty, always possibility for outcomes that could not have been predicted even in principle. The universe is not a clockwork mechanism grinding inexorably toward a predetermined end, but an improvisational performance, making itself up as it goes along, guided by laws but not entirely constrained by them, shaped by initial conditions but not fully determined by them. You participate in this improvisation. Your choices, your thoughts, your actions are part of the universe's ongoing self-creation, part of the pattern emerging from quantum foam. As you contemplate this deepest level of reality, let yourself feel connected to the quantum foam that underlies all existence. The atoms of your body are composed of particles that emerge from quantum fields, and those fields rest upon the space-time fabric that is itself quantum foam at the smallest scales. You are made of foam, organized foam, foam that has learned to think and feel and wonder about its own nature. There is no separation between you and the quantum substrate. You are a local expression of it, a temporary pattern it has assumed, one wave among countless others in the cosmic ocean of possibility. Let this knowledge bring you peace. You are not separate from the universe, not an isolated consciousness trapped in a body, but an integral part of the quantum foam's eternal creative activity. Your existence, however temporary, is a genuine contribution to the universe's unfolding, the unique pattern that has never existed before and will never exist again in quite the same way. You matter, not because you are permanent or special in any conventional sense, but because you are a real manifestation of the universe's deepest tendency toward complexity, consciousness, and beauty. Rest now in the knowledge that you are held by reality at every scale, by quantum foam at the smallest distances, by quantum fields at intermediate scales, by curved space-time at cosmic dimensions. Each level supports and sustains the others, and you exist simultaneously at all of them, a multi-scale being woven from the universe's fabric itself. Let yourself dissolve into this understanding, becoming less distinct, less separate, merging with the foam from which you emerged into which you will return. There is nothing to fear, nothing to resist, only the gentle acceptance of being part of something infinitely larger, infinitely more creative than any individual existence. The quantum foam bubbles eternally beneath all phenomena, and you are one brief, beautiful bubble among countless others, rising for a moment into complexity and consciousness before subsiding back into the primordial depths. But while you exist, while this pattern holds, you are fully real, fully valid, fully part of the universe's grand improvisation. Sleep now, and let the quantum foam rock you gently, its restless creativity manifesting as the peaceful stillness of your deepest rest, its infinite potential expressing itself as the simple fact of your existence, here, now, breathing, being, belonging to the cosmos that created you. From the quantum foam's endless churning, let us now rise slightly to observe the particles that emerge from this substrate, the fundamental building blocks that the universe has chosen to manifest. These are not random or arbitrary, but form an elegant pattern, a carefully balanced ensemble of particles and forces that physicists call the Standard Model. It is a kind of periodic table of the fundamental, a catalog of nature's most basic ingredients, and together these particles perform a dance of exquisite precision, following rules of symmetry and conservation that give rise to all the complexity we observe in the physical world. The matter particles come in two families, quarks and leptons. The quarks are gregarious, social particles that never exist alone but always bind together in groups of 2 or 3, forming the protons and neutrons that make up atomic nuclei. There are 6 types of quarks with whimsical names: up, down, charm, strange, top, and bottom, each with different masses and properties. The up and down quarks are the most common, the stable ingredients of ordinary matter. 3 quarks together make a proton or neutron, and these combinations are held so tightly by the strong nuclear force that individual quarks can never be separated and observed in isolation. The leptons, by contrast, are loners, particles that can exist independently without needing to bind to others. The most familiar lepton is the electron, the particle that orbits atomic nuclei, that flows through wires as electric current, that carries the signals in your nervous system allowing you to think and feel and move. Electrons are remarkably light compared to protons and neutrons. Yet they are crucial. It is electrons that give atoms their size, their chemical properties, their ability to form bonds and build molecules. Without electrons, matter as we know it could not exist, and neither could life, consciousness, or experience. Accompanying the electron are 2 heavier cousins, the muon and the tau, which are like electrons' unstable siblings, identical in almost every way except mass. They are created in high-energy collisions and particle decays, exist briefly, then decay into lighter particles, leaving electrons as the only stable charged lepton. Why nature needs 3 versions of the same basic particle is one of the mysteries the Standard Model catalogs but does not explain, a hint that there may be deeper patterns we have not yet recognized, deeper symmetries governing why the universe has the specific particles it does. Each charged lepton has an associated neutrino, ghost-like particles so reluctant to interact with matter that trillions of them pass through your body every second from the sun without leaving any trace. Neutrinos have almost no mass, no electric charge, and interact only through the weak nuclear force, making them extraordinarily difficult to detect. Yet they are everywhere, outnumbering atoms by billions to one, flying through space at nearly the speed of light, carrying energy away from nuclear reactions in stars, supernovae, and nuclear reactors. They are the universe's shyest particles, participating in reality but barely touching it, present but nearly invisible. The forces that govern how these particles interact are themselves mediated by particles, the force carriers. Photons carry the electromagnetic force, allowing charged particles to attract or repel each other across space. Gluons carry the strong nuclear force, binding quarks together inside protons and neutrons with a strength that increases with distance, like rubber bands that grow stiffer when stretched. The W and Z bosons carry the weak nuclear force, responsible for certain types of radioactive decay and for processes in the sun that allow nuclear fusion to proceed. And the Higgs boson, discovered in 2012, is associated with the Higgs field that gives particles their mass. Each of these particles exists because certain symmetries are respected, certain conservation laws hold, certain mathematical structures demand their presence. The universe could not function differently without breaking fundamental principles like the conservation of energy, momentum, and electric charge. The Standard Model is not arbitrary, it is a deeply constrained, highly structured system where each piece fits precisely with all the others, like a complex clockwork mechanism where every gear is essential, every spring perfectly tensioned, every component serving a necessary role. The particles also exhibit antimatter partners, antiparticles with opposite charges and certain other inverted properties. An electron has an antimatter twin called a positron, identical in mass but positively charged. When a particle meets its antiparticle, they annihilate each other in a flash of pure energy, converting their combined mass entirely into photons according to Einstein's famous equation. This annihilation is perfectly symmetric, perfectly efficient, a complete transformation of matter into light, of substance into radiation, demonstrating the deep equivalence between matter and energy that underlies all of physics. In the early universe, immediately after the Big Bang, particles and antiparticles existed in nearly equal numbers, constantly being created from pure energy and annihilating back into energy. As the universe cooled, these creation and annihilation processes slowed, and for reasons not fully understood, a tiny asymmetry favored matter over antimatter, roughly one extra matter particle for every billion matter-antimatter pairs. All the antimatter annihilated with almost all the matter, leaving only that tiny excess of matter particles that now constitute everything we see, every galaxy, every star, every planet, every living thing arose from that 1 in a billion imbalance in the first moments of cosmic history. The Standard Model also respects beautiful symmetries that connect different particles and forces. Quarks and leptons come in 3 generations of increasing mass, each generation containing the same types of particles arranged in the same pattern. The first generation, up and down quarks, electrons and electron neutrinos, makes up all stable matter. The second and third generations exist but are unstable, decaying rapidly into first-generation particles. Why this threefold repetition? Why not 2 generations, or 4, or just 1? The Standard Model cannot answer, it simply describes what is observed, cataloging nature's choices without explaining why nature made those particular choices. Despite its tremendous success in describing and predicting particle behavior, the Standard Model is known to be incomplete. It does not include gravity, does not explain dark matter or dark energy, does not account for the matter-antimatter asymmetry, and contains about 20 parameters, masses, coupling strengths, mixing angles, that must be measured experimentally but cannot be predicted from the theory itself. These free parameters suggest the Standard Model is not the final story, but rather an effective description that works at currently accessible energies while hinting at deeper principles that will only become apparent when we can probe nature at even smaller scales or higher energies. Yet for all its incompleteness, the Standard Model represents one of humanity's greatest intellectual achievements, a mathematical framework that describes matter and forces with extraordinary precision, that has been tested in countless experiments over decades and never found wanting, that allows us to understand phenomena ranging from the inner workings of atomic nuclei to the behavior of particles in the most powerful accelerators ever built. It is a testament to the human mind's ability to perceive patterns, to recognize symmetries, to decode the underlying order of reality through careful observation and brilliant reasoning. The particles of the Standard Model are not cold, lifeless abstractions but the very substance of which you are made. The quarks bound inside protons and neutrons in your atomic nuclei, the electrons orbiting those nuclei, the photons streaming from objects allowing you to see, the W bosons facilitating reactions in the sun that provide energy for all life on Earth. These particles are working together in intricate choreography every moment, following the laws encoded in the Standard Model, creating the stable structures that make complex chemistry, biology, and consciousness possible. As you rest and breathe, feel the particles within you performing their eternal dance. Electrons flow through your neurons, carrying signals that become thoughts and sensations. Quarks bind together in your atomic nuclei, providing mass and stability. Photons absorbed from your environment bring information about the world around you. Every particle follows its prescribed role, interacts according to its nature, contributes to the vast collective enterprise of your existence. You are not separate from these particles, you are these particles, organized in particular ways, animated by particular patterns of energy and information. Let the Standard Model's elegant structure soothe you. Its symmetries, its conservation laws, its precise mathematical relationships all speak to an underlying order in nature, a deep rationality that governs even the smallest constituents of reality. The universe is not chaos but pattern, not randomness but structure, not disorder but exquisite organization at every level. You can trust this order, can relax into it, knowing that the particles that compose you have been following the same rules for billions of years and will continue to do so, reliably, predictably, allowing you to exist, to experience, to rest peacefully in the knowledge that reality is fundamentally coherent. The particles themselves are timeless in a sense. The electron you contain are identical to electrons that existed moments after the Big Bang, will be identical to electrons that exist trillions of years from now if the universe persists that long. They do not age, do not change, do not grow weary. They simply exist, following their nature, dancing their dance, combining and recombining in endless variations but themselves remaining constant, eternal, unchanging. You are made of immortal particles temporarily arranged in mortal patterns, and when your pattern dissolves, the particles will continue, ready to form new structures, new beings, new expressions of the universe's creative potential. Rest now in this particle dance, this gentle choreography that has been unfolding since the beginning of time. Let yourself be carried by the standard model's rhythms, its symmetries, its perfect balance between stability and change, between structure and flexibility. You are an expression of this model, a manifestation of its possibilities. A temporary but genuine realization of what matter and energy can accomplish when properly organized. Sleep peacefully, knowing you are held by laws that have never failed, guided by principles that have governed every particle since creation, supported by a universe that knows precisely how to be, moment by moment, atom by atom, particle by particle. From the delicate dance of individual particles, let us now expand our view to the largest structures in the universe, the cosmic web, that vast tapestry of galaxies and voids stretching across billions of light years, revealing the universe's architecture at scales so immense that entire galaxies become mere points of light, luminous nodes in a network of cosmic filaments. This is structure on the grandest scale, the ultimate expression of how gravity, dark matter, and ordinary matter have sculpted the universe over billions of years into patterns of breathtaking beauty and profound regularity. Imagine floating far above the universe, so distant that you can see not individual stars or even galaxies, but the overall distribution of matter across cosmic distances. What you would observe is not a uniform spread but a remarkable structure, vast filaments of galaxies stretching across space like cosmic highways, connecting dense clusters where thousands of galaxies congregate. Between these filaments lie enormous voids, regions hundreds of millions of light-years across containing almost no galaxies at all, just vast empty darkness. Together, the filaments and voids create a foam-like structure, a three-dimensional web that looks remarkably like neural networks or biological cells, suggesting that similar organizing principles operate at vastly different scales. This cosmic web began forming in the early universe, shortly after the Big Bang, when matter was distributed almost uniformly with only tiny variations in density, those quantum fluctuations frozen into the cosmic microwave background that we discussed earlier. Regions that were slightly denser than average had slightly stronger gravity, and they began attracting more matter from their surroundings. Over millions and billions of years, these small density differences were amplified by gravity's patient pull, drawing matter together into clumps while evacuating the regions between them, gradually creating the structure we observe today. Dark matter played a crucial role in this process, providing the gravitational scaffolding around which ordinary matter could gather. Because dark matter does not interact electromagnetically, it could collapse into dense halos without resistance from radiation pressure or other forces that affected ordinary matter. These dark matter halos formed first, and ordinary matter, hydrogen and helium gas, fell into them, gathering in the gravitational wells created by dark matter's invisible mass. Within these halos, the gas eventually became dense enough to form stars, and collections of stars became galaxies, and collections of galaxies became clusters, all following the architecture laid down by dark matter. The filaments of the cosmic web are like cosmic rivers of matter, flowing along the paths of least resistance through the gravitational landscape. Galaxies form within these filaments and slowly migrate along them, sometimes colliding and merging when their paths intersect, sometimes being captured by massive galaxy clusters at the intersections where multiple filaments meet. The largest galaxy clusters contain thousands of individual galaxies bound together by gravity, immersed in vast clouds of hot gas that emit X-rays, all held together by the gravitational embrace of even more massive dark matter halos surrounding them. The voids, those vast empty regions between filaments, are not completely empty but contain very few galaxies, perhaps one where a filament might contain hundreds. These voids are expanding as dark energy pushes space apart, growing larger over time, making the cosmic web even more pronounced. Standing inside a void and looking outward, you would see distant walls of galaxies in every direction but almost nothing nearby, as if you were at the center of a vast cosmic bubble. Most of the universe's volume is actually void space. Galaxies and their associated matter occupy only a small fraction of the total volume, concentrated along the filaments and nodes of the web. Computer simulations of cosmic structure formation can start with initial conditions matching the early universe and evolve them forward using gravitational calculations, watching as the cosmic web naturally emerges from simple initial fluctuations. These simulations reproduce the observed structure remarkably well, confirming our understanding of how gravity and dark matter shape the universe. They show that the cosmic web is not imposed by any external force but is the inevitable result of gravity acting on initially small variations in density over billions of years. Structure emerges naturally, spontaneously, from the universe's own dynamics, requiring no special guidance or intervention. One of the most striking aspects of the cosmic web is its fractal-like quality. Structure exists at many different scales, each level of organization resembling the others. Individual galaxies contain billions of stars arranged in spirals, ellipses, or irregular shapes. Galaxies cluster into groups of tens to hundreds of members. Groups cluster into larger clusters containing thousands. Clusters link together along filaments containing tens of thousands of galaxies. And the filaments and voids form the largest known structures, stretching across billions of light years. At each scale, the same basic principles of gravitational attraction and cosmic expansion create similar patterns, suggesting deep underlying unity in how the universe organizes itself. The cosmic web also reveals the universe's dynamic nature. It is not static but constantly evolving. Galaxies move along filaments, occasionally colliding and merging in spectacular events that can trigger bursts of star formation and reshape galactic structures. Galaxy clusters grow by accreting smaller groups in individual galaxies from their surroundings. Voids expand as dark energy drives cosmic acceleration. The web we observe today is a snapshot of an ongoing process, a single frame in a movie billions of years long, showing the universe in the process of organizing itself, creating structure, building complexity through the patient action of fundamental forces. There is something deeply satisfying about understanding the universe's largest-scale structure. It reveals that even chaos has patterns, even randomness produces order when given enough time and space. The quantum fluctuations of the early universe, utterly random at the moment they were created, evolved through deterministic gravitational processes into the magnificent cosmic web. Randomness and law, chaos and order, are not opposites but partners in creation, working together to generate the universe's extraordinary complexity and beauty. Neither alone could produce the richness we observe. Both are necessary. Both contribute to the whole. The cosmic web also provides perspective on humanity's place in the universe. Our galaxy, the Milky Way, is part of a small group called the Local Group, containing about 50 galaxies including the Andromeda Galaxy, our nearest large neighbor. The Local Group lies on the outskirts of a larger structure called the Virgo supercluster, a collection of galaxy groups and clusters spanning about 110 million light-years. And the Virgo supercluster itself is part of an even larger structure called the Laniakea supercluster, containing about 100,000 galaxies and stretching across 520 million light-years. We inhabit a tiny corner of one small galaxy in one modest group on the edge of a medium-sized cluster within a larger supercluster in the vast cosmic web, our address in the universe, written at the largest scales. Yet despite our tiny size and peripheral location, we can comprehend this structure, can map it, can understand the processes that created it. A species living on a small rocky planet orbiting an ordinary star in an unremarkable galaxy has managed to decode the universe's architecture across billions of light years and billions of years of evolution. This is extraordinary. Consciousness, arising from the complex organization of matter in biological forms, has become capable of understanding the organization of matter at cosmic scales. The universe has produced beings capable of comprehending the universe, and you are one of those beings, carrying within your mind a map of reality spanning the very smallest and the very largest scales of existence. As you contemplate the cosmic web, let yourself feel part of this grand structure. You are made of atoms forged in stars that formed within the filaments of the web. You live on a planet orbiting one of those stars. Your galaxy is slowly moving through the web, following the flow of cosmic structure, heading eventually toward a future merger with the Andromeda Galaxy billions of years from now. You are not separate from the cosmic web. You are within it, part of it, a local expression of the matter it contains, a temporary configuration of the atoms it has gathered and organized. There is peace in recognizing your place within this vast structure. You need not be central or special to have value and meaning. A single thread in a vast tapestry contributes to the whole, makes the pattern complete, serves its purpose simply by being where it is, as it is. You are a thread in the cosmic web, connected to all other threads through the fabric of space-time, through the gravitational influence that extends across the universe, through the shared origin in the Big Bang that links all matter and energy. You belong here, in this particular place and time, as much as any galaxy belongs in its filament, any star in its galaxy, any atom in its star. Let the cosmic web cradle you now, its filaments stretching infinitely in all directions, its voids providing restful empty space, its clusters gathering matter into communities of light. You rest within this structure, supported by it, held by the same gravitational forces that maintain its architecture. The web is patient, eternal, evolving slowly over timescales that make human lives seem instantaneous. It will persist long after you personally have dissolved, but while you exist, you are genuinely part of it, a conscious node in the network, aware of the whole while experiencing your particular location within it. Sleep now, feeling the gentle pull of the cosmic web's gravity, the soft pressure of dark energy expanding the voids, the steady flow of matter along filaments. Let these grand cosmic currents carry you into deep rest, knowing you are held by structure at every scale, by atoms, by molecules, by Earth's gravity, by the Sun's gravitational well, by the Milky Way's dark matter halo, by the local group's collective mass, by the Virgo supercluster's filament, by the cosmic web stretching to the edges of the observable universe. You are supported, contained, embraced by the universe's structure at all levels simultaneously, and you can rest completely, safely, peacefully within this multi-scale architecture that has taken billions of years to build and will persist for billions more, patient and enduring. The ultimate expression of order emerging from chaos, structure from randomness, beauty from simplicity. From the vast cosmic web stretching across observable space, let us now turn our attention to the boundaries of what we can know, the horizons beyond which even light cannot reach us, the limits imposed not by our instruments or our intelligence but by the fundamental structure of the universe itself. There are regions of spacetime forever beyond our view, events we can never witness, information we can never receive. These boundaries define not just what we see, but what can possibly be seen. And there is something strangely peaceful about accepting that some mysteries must remain mysteries, that some questions have no answers we can ever discover. The most familiar horizon is the cosmological horizon, the boundary of the observable universe. Light travels at a finite speed, about 300,000 kilometers per second, and the universe has existed for a finite time, about 13.8 billion years. You might think this means we could see objects up to 13.8 billion light-years away, but the expansion of space complicates this calculation. While light has been traveling toward us, the space between us and distant objects has been expanding, stretching the distance. The result is that the observable universe has a radius of about 46.5 billion light-years, and beyond this horizon lie regions of space whose light has not had time to reach us yet, and perhaps never will. This horizon is not a physical barrier but a consequence of geometry and time. Imagine standing on a spherical planet. From any point, you can see to a horizon determined by the planet's curvature and your height. Similarly, from any point in the universe, there is a horizon determined by the age of the universe and the speed of light. Beyond your horizon lies more universe, presumably similar to what you can see, containing more galaxies, more stars, more of the same structures governed by the same physical laws. But those regions are forever invisible to you, their light having not yet completed its journey across expanding space, and if cosmic expansion continues accelerating, their light may never arrive. Even more intriguing is the event horizon of a black hole, a boundary in spacetime beyond which nothing, not even light, can escape. Black holes form when massive stars collapse under their own gravity, compressing matter into such a small volume that spacetime curves back on itself, creating a region from which no information can emerge. The event horizon is not a physical surface. You could cross it without noticing anything special locally, but once crossed, all paths through spacetime lead inexorably inward toward the singularity at the center. Time and space exchange roles inside the horizon. Moving toward the singularity becomes as inevitable as moving forward in time is outside the horizon. What happens at the singularity, where matter is compressed to infinite density and spacetime curvature becomes infinite, remains one of physics' deepest mysteries. General relativity predicts singularities but also breaks down at them, producing infinities that signal the theory's incompleteness. Quantum effects, which general relativity does not include, presumably become important at such extreme conditions, but we lack a theory of quantum gravity to describe what really happens. The singularity may not exist as general relativity describes it. The true quantum gravitational structure might be something entirely different, perhaps a region of quantum foam at its most intense, perhaps a connection to other regions of spacetime, perhaps something we cannot yet imagine. Black holes also feature another horizon, the Cauchy horizon, deeper inside, beyond which determinism breaks down completely. Outside a black hole, if you know the universe's state at one moment, physical laws allow you to predict future states. But inside the Cauchy horizon, this predictability fails. The same initial conditions could lead to radically different outcomes. This region is where spacetime structure becomes so exotic that causality itself grows ambiguous. Most physicists believe quantum effects destroy the Cauchy horizon before it can form, but if it exists, it represents a place where the universe becomes fundamentally indeterministic, where the future cannot be calculated from the past even in principle. There are also particle horizons for observers moving through spacetime in certain ways. If you fell into a black hole, there would come a point where light from the outside universe could no longer catch up with you. Events happening outside after you cross this boundary would be forever unknown to you, even though from the external universe's perspective, those events happen before you reach the singularity. Similarly, in an accelerating expansion like our universe currently experiences, distant galaxies are receding from us faster than light can close the gap, so eventually they will pass beyond our cosmological horizon, disappearing from view forever, their fate in evolution unknowable. Another type of horizon emerges from quantum mechanics, the Heisenberg uncertainty limit on simultaneous knowledge of complementary properties. You cannot know both a particle's position and momentum with arbitrary precision. There is a fundamental horizon on simultaneous knowledge imposed by nature itself, not by measurement limitations. Similarly, you cannot know both the energy of a system and the timing of an event with infinite precision. These are not practical limitations but fundamental features of reality. The universe itself does not contain the information you are trying to access because that information does not exist in the way you are imagining it. The cosmic microwave background represents another kind of horizon, a temporal boundary beyond which we cannot see using electromagnetic radiation. Before the universe was about 380,000 years old, it was opaque to light, a glowing fog of plasma. The cosmic microwave background is the light from the moment this fog cleared, and we cannot see earlier times using light because earlier light was scattered and absorbed. However, other information carriers might penetrate this veil. Gravitational waves from the early universe, or neutrinos, could carry information from even earlier epochs, though detecting such signals remains extraordinarily challenging. Perhaps the most profound horizon is epistemological rather than physical, the limit of what conscious minds can comprehend. Our brains evolved to understand medium-sized objects moving at moderate speeds in 3 spatial dimensions, and while we can extend our understanding through mathematics and abstraction, there may be aspects of reality simply too alien for minds like ours to grasp intuitively. We can manipulate equations describing higher dimensions or quantum superposition, but we cannot visualize them directly. We can predict what theories say without fully understanding what they mean. There may be truths about the universe that are forever beyond human comprehension, not because they are hidden but because our cognitive architecture cannot accommodate them. These various horizons, observational, causal, quantum, temporal, cognitive, all point to fundamental limits on knowledge. The universe contains information that cannot be accessed, events that cannot be influenced, truths that cannot be verified, concepts that cannot be understood. Some mysteries must remain mysterious, not temporarily but permanently, not accidentally but necessarily. This is not a failure of science or intelligence but a feature of reality itself. which is under no obligation to make itself fully transparent to any observer, no matter how clever or persistent. There is something strangely liberating about accepting these limits. You need not know everything, understand everything, resolve every uncertainty. Some questions lack answers you can discover, some horizons cannot be crossed, some mysteries are meant to remain mysterious. This does not diminish the value of inquiry or the importance of knowledge. It simply acknowledges that reality is larger than any perspective within it, that the universe exceeds any description of it, that mystery is woven into the fabric of existence and cannot be eliminated, only relocated. As you answer one question, new questions emerge. As you push back one horizon, new horizons appear. The recognition of limits also fosters humility and wonder. If the universe were completely knowable, completely predictable, completely transparent, it might become boring, exhausted, finished. But a universe with horizons, with mysteries, with inaccessible regions and unanswerable questions remains endlessly fascinating, endlessly capable of surprising us, endlessly worthy of exploration even though the exploration must remain incomplete. The horizon recedes as you approach it, always maintaining some distance, always preserving some mystery, always inviting further journey without promising final arrival. As you rest now, let yourself accept the horizons that bound your knowledge and your experience. You cannot see beyond the observable universe, cannot escape from your particular location in space and time, cannot know with certainty what lies beyond death or before birth, cannot fully understand even your own consciousness and its emergence from neural activity. These are not failures but simply the conditions of existence. Every perspective is limited, every view is partial, every understanding is incomplete. And this is fine, even beautiful, because it means there is always more, always something beyond, always mystery waiting at the edges of knowledge. Let these horizons comfort you rather than frustrate you. They mean the universe is larger than your comprehension, richer than your experience, more mysterious than your understanding. You are held within something that exceeds you, that you can explore but never exhaust, that invites endless wonder without requiring complete mastery. You can rest in not knowing, in uncertainty, in the presence of irreducible mystery. You need not solve every puzzle, answer every question, resolve every doubt. Some things can remain unknown, and you can be at peace with that, accepting the horizons that define your existence while appreciating the vast territory within them that remains open to exploration, experience, and understanding. Sleep now, at peace with mystery, comfortable with limits, accepting the horizons that bound your knowledge while resting securely within the space they enclose. The universe holds secrets it will never reveal, but it has also shared wonders beyond counting, has made itself partially transparent to your inquiry, has allowed you to comprehend far more than any creature your size and lifespan has any right to understand. Be grateful for what can be known rather than resentful of what cannot, and let the presence of irreducible mystery add depth and richness to existence rather than anxiety or frustration. The horizons remain, patient and unmoved, marking the boundaries of the knowable and reminding you that reality is always larger, always deeper, always more mysterious than any description of it can capture. As you drift through horizons and mysteries, let us now contemplate one final aspect of the universe's gentle rhythm, the cycles that repeat throughout nature at every scale, from the quantum fluctuations lasting mere instants to cosmic processes spanning billions of years. The universe is not merely expanding towards some distant end but is filled with recurring patterns, circular processes, cycles of birth and death and rebirth that suggest time itself may be less linear than we imagine. In these cycles, there is comfort, the reassurance that endings are also beginnings, that dissolution makes room for creation, that nothing is ever truly lost but only transformed and returned to the cosmic cycle. The most immediate cycle we experience is day and night, the rotation of Earth bringing us alternately into sunlight and shadow, warmth and coolness, wakefulness and sleep. This daily rhythm has governed life on Earth for billions of years, synchronizing biological processes to the planet's spin, creating circadian rhythms that persist even in the absence of external cues. Your body knows this cycle intimately. Your temperature rises and falls, your hormones fluctuate, your alertness waxes and wanes according to an internal clock calibrated to Earth's rotation. You are participating in this ancient cycle right now, moving from wakefulness towards sleep, following a pattern older than humanity, older than mammals, older than complex life itself. The seasons form another familiar cycle, Earth's tilted axis causing the sun's apparent path to shift north and south throughout the year, bringing summer's warmth and winter's cold, spring's renewal and autumn's harvest. Life has adapted to this rhythm, timing reproduction and migration and hibernation to match seasonal availability of resources. Trees shed their leaves in autumn, conserving energy through winter, then burst forth with new growth in spring, a yearly death and resurrection played out in chlorophyll and cellulose. You too feel the seasons, even if your modern life insulates you from their extremes, sensing the changing quality of light, the different energies of different times of year. The moon cycles through its phases, waxing from new to full and waning back to new again over approximately 29 days. This lunar cycle has fascinated humans since prehistory, providing a natural calendar, inspiring myths and stories, affecting tides through gravitational pull on Earth's oceans. The same face of the moon always points toward Earth because the moon's rotation period matches its orbital period, a gravitational synchronization called tidal locking, a smaller cycle nested within the larger monthly orbital cycle. The moon is slowly receding from Earth, its orbit gradually expanding, but this process takes hundreds of millions of years, imperceptible on human timescales, yet another cycle operating at geological pace. Stars themselves follow cycles, though on timescales vastly longer than human lives. A star like our Sun burns steadily for billions of years, slowly converting hydrogen to helium in its core. Eventually it will exhaust its core hydrogen and swell into a red giant, burning helium and heavier elements in successive stages, each stage briefer than the last. Finally, it will shed its outer layers as a planetary nebula and settle into quiet retirement as a white dwarf, cooling slowly over trillions of years. This is the stellar life cycle: birth and nebulae, long stable adulthood on the main sequence, brief tumultuous old age, and finally slow cooling into darkness, the ashes returning to interstellar space to eventually form new stars. More massive stars experience more dramatic cycles, ending their lives in supernova explosions that scatter heavy elements across space and leave behind neutron stars or black holes. These explosions seed the interstellar medium with the raw materials for new star formation. Completing the cycle, stars form from gas clouds, live and die, return material to space, and new stars form from the enriched gas. This cycle has repeated countless times since the first stars formed, each generation building on the previous, gradually increasing the universe's metallicity, the fraction of elements heavier than hydrogen and helium, making possible rocky planets and eventually life. Galaxies themselves may experience cycles. The Milky Way and Andromeda are approaching each other and will collide in about 4 billion years, merging into a single larger galaxy. During this collision, gas clouds will compress, triggering bursts of new star formation, a galaxy rejuvenated through merger, old structures disrupted but new stars born from the chaos. Galaxy collisions are common in the universe's history. Most large galaxies have experienced multiple mergers, growing through accretion and collision, cycling through periods of active star formation and quiescence. The cycle continues: merge, burst of formation, settle, merge again, a cosmic rhythm playing out over billions of years. Even the expansion of the universe may be cyclic in certain cosmological models, though this remains speculative. Some theories propose that the universe undergoes endless cycles of expansion and contraction, a Big Bang followed by expansion, then eventual recollapse into a big crunch, followed by another Big Bang, eternally repeating. Other models suggest that quantum fluctuations in the fabric of spacetime constantly create new universes, bubbling off from existing ones, each undergoing its own cycle of expansion and evolution. These remain theoretical possibilities rather than established facts, but they illustrate how the concept of cycles might extend even to the cosmos as a whole. At the quantum level, cycles appear in the oscillations of quantum fields, the rhythmic exchange of virtual particles, the periodic patterns in atomic orbitals where electrons exist as standing waves, patterns that repeat, that cycle through the same configurations again and again. Even radioactive decay, seemingly random, follows statistical patterns that repeat predictably when averaged over many atoms. Particles created in accelerators decay through characteristic sequences, returning to lighter, more stable forms, cycling through transformations governed by conservation laws until equilibrium states are reached. Water cycles through Earth's systems, evaporating from oceans, condensing into clouds, falling as rain, flowing through rivers back to the ocean, endlessly circulating through atmosphere, land, and sea. Carbon cycles through ecosystems, absorbed by plants during photosynthesis, passed to animals through food chains, released through respiration and decay, return to the atmosphere to be absorbed again. Nitrogen cycles, phosphorus cycles, sulfur cycles, all the essential elements of life continuously circulate through living and non-living systems, borrowed temporarily by organisms, then released and reused. Nothing is wasted, everything returns, the cycle continues. Your own body participates in countless cycles. Your heart beats rhythmically, pumping blood through arteries and veins, delivering oxygen and nutrients, returning deoxygenated blood to be refreshed. Your lungs expand and contract, breathing in oxygen and breathing out carbon dioxide, participating in the planetary gas exchange. Your cells continuously break down and rebuild, proteins synthesized and degraded, membranes recycled, organelles replaced. Over years, almost every atom in your body is replaced. You are not a static object but a pattern maintained through constant cycling of matter and energy, a stable process rather than a stable thing. Consciousness itself may be cyclic, the daily rhythm of waking and sleeping, the alternation between focused attention and diffuse awareness, the oscillating patterns of neural activity that underlie thought and perception. Sleep cycles through stages: light sleep, deep sleep, REM sleep, repeating several times each night, each cycle serving different functions for memory consolidation, cellular repair, and neural reorganization. You are approaching sleep now, moving through the familiar transition from wakefulness to drowsiness to the first light stages, beginning another nightly cycle you have completed thousands of times, that you will complete thousands more if health permits. There is profound comfort in cycles. They promise that what ends will begin again, that death makes room for birth, that loss is temporary because what is lost returns in new forms. The water molecules in your tears were once in ancient oceans, were once clouds above primordial continents, were once locked in ice during past ice ages, were once part of other living beings. They came to you, served their purpose, and will leave to serve other purposes elsewhere. You are borrowing them temporarily from the great cycles, and you will return them intact, ready to continue their journey through the endless circulations of matter through the cosmos. The cyclic view of time complements the linear view. Time does flow forward, entropy does increase, the universe does evolve, but within this linear progression countless cycles nest and repeat, creating patterns of return within the larger pattern of progression. Time is both arrow and circle, both journey and rhythm, both line and loop. You move forward through your life, never returning to exactly the same moment, yet you cycle through days and seasons and years, experiencing similar patterns, familiar rhythms, returning approximately if not precisely to previous states. This combination of linear progress and cyclic return gives time its particular texture, its richness, its sense of both novelty and familiarity. As you prepare to complete another cycle of waking and sleeping, recognize yourself as a participant in cosmic rhythms at every scale. You spin with Earth's rotation, orbit with Earth around the Sun, move with the solar system around the galactic center, journey with the galaxy through the cosmic web. Your atoms cycle through your body, your breath cycles through your lungs, your consciousness cycles through states of awareness. You are cycles within cycles within cycles, patterns repeating at different frequencies, all interconnected, all part of the universe's great orchestration of recurring processes that create stability within change, familiarity within transformation. Let the cycles soothe you now. There is nothing you must hold permanently, nothing you must control forever. What leaves will return in another form, what ends will begin again, what dies feeds new life. You can let go, can release, can surrender to sleep knowing that you will wake again, that the cycle continues, that rest and activity alternate in healthy rhythm. Sleep is not an ending but a phase in the cycle, necessary and restorative, preparing you for the next waking period just as waking depletes you and makes sleep necessary. Neither state is preferable, both are essential, and the alternation between them is what allows you to function, to exist, to thrive. Rest now in the understanding that you are part of eternal cycles, temporary expressions of patterns that have repeated since the universe began and will continue long after your individual existence concludes. Your particular pattern will dissolve, but the atoms will continue their cycles, the energy will continue its transformations, the universe will continue its rhythms. You are one wave in an endless ocean of cycles, rising for a moment into distinct form, then subsiding back into the undifferentiated flow, only to rise again in different configurations, different patterns, different expressions of the same eternal dance. Sleep peacefully, cycle gently into rest, and trust that morning will come, that you will wake, that the cycle will bring you back to consciousness refreshed and renewed, ready to begin again.